Hi, everyone. I'm super excited about being here today. As some of us will be flying soon, I want to start with a question about airplanes. So, do you think airplanes, with a show of hands, have a fuel gauge? Yeah, and you're all correct. And now it will be a bit more complicated with show of hands, but try to think what happens if the fuel gauge is broken and it can't be fixed on site, right? So if you thought about a dipstick measurement like you have in your car, then you'd be correct. And this is what is being done when the fuel gauge is off. There is a process where you can go and do a dipstick measurement in the fuel tanks, usually located on the wings, and then calculate how much fuel the aircraft has. And that's exactly what happened with Air Canada Flight 143 on July 23rd, 1983. Before the 787 plane took off from Ottawa, the pilot, Bob Pearson, he was under the impression that the fuel gauge was broken, so he ordered a dipstick measurement. And then he took those measurements and he input them into the flight computer. And the flight took off, right, to Edmonton. And shortly after dinner was served, the plane was in 12.5 kilometers up and 870 kilometers per hour. An alarm went off for the left engine fuel pressure, right? And so the pilots didn't think it was a big issue. They thought it either had to be something with the fuel pump or some computer malfunction. And since the engines can still take fuel, even if the fuel pump is broken, they didn't think it's a big deal. But then, shortly after, an alarm went off for the right fuel pressure. And shortly after, the left engine went off. At that time, they started planning their emergency landing. And while they were planning the emergency landing, also the right engine turned off. This is when they heard from the plane control system a very loud bong. So they are experienced professionals, and so the co-pilot opened the flight manual, and he was searching for the chapter with the instructions on what to do when both engines are out. Unfortunately, he didn't find such chapter on the manual. But luckily, a plane, like our production systems, have many auxiliary systems that should help us during such production incident, right? And let's see how these different systems fared in that situation. So first, we have the auxiliary power unit, right? So if we can't get power from the engine, maybe we can power our instruments using the additional power unit that we have. However, this power unit didn't work at all. And the reason being, they both rely on the same infrastructure. They both rely on the same fuel tanks. Another system that we have is, you can think about it as our dashboard, right? We have an electronic flight instrument systems. And since most of the instruments relied on power coming from either the APU or the engine, then most of the instruments were off, except for some instruments that were battery powered. And one of the most important instruments to fly what essentially is now a glider is the vertical speed indicator, because we want to know how fast we're losing altitude so we can land somewhere or to plan our landing. And they couldn't do that, so they had to talk to the air control tower and do these calculations manually. Another subsystem we have is the ram air turbine. It's a turbine that opens up in case of an emergency and it should provide hydraulics to navigate the plane for the pilot. And this actually was deployed successfully and worked, except when the pilot was maneuvering to land, and it did something that's called a side slip, and less air went through the turbine, so we had less control over the aircraft exactly at the time when he was trying to land it. Finally, there's the landing gear. And the way to open a landing gear in a plane is also hydraulics, but the ram air turbine doesn't provide hydraulics for the landing gear. So they resorted to an older method, gravity. And so the landing gear was opened by gravity, and for the main gear, it was dropped and locked. But for the nose gear, it was dropped and didn't lock. Since I don't want to make all this talk about an aircraft incident, I'll just tell you, and you probably want to go home feeling a bit more safe in the airplane, that nothing bad happened. The pilot was a very experienced glider pilot, and he managed to find an airstrip and land the plane without any injuries during landing. There were some injuries when people went through the inflating slides to the curb. And the aircraft was fully repaired and back in service. But by now, you're probably asking yourself two questions. Who is this person, and why is he talking to me about airplanes? So maybe I'll go back to the beginning. My name is Nati Cohen. I have something like 20 years of experience with causing production incidents and maybe solving some of them. Regarding the second question, I think there is a lot we can take from that story. And I'll try to expand on that. So the main thing our CTO likes to say is everything fails all the time. And this is true, right? We have conferences about this stuff. Our production systems fail, our pipelines fail, development environment fail. The services we build fail, and the services we buy fail. And what I want to focus on in this talk is even the systems that we have in place to assist us when our production system fail, these systems also fail, right? And this is actually all the systems that we have and rely on, even without thinking about them, right? So there are communications platforms like, I don't know, Slack or Zoom or Team or WebEx, right? They all have had outages in the past 2 years, which makes sense. Systems have outages. Monitoring and paging system have outages, right? And it doesn't matter if it's a system we build or a SaaS system that we use. And even AWS had an issue with Kinesis that affected CloudWatch for some customers. Finally, even systems like our source control or the Jira that we love so much can also fail and have outages. And this can happen like in parallel to our production incidents. And it's not just outages, right? Outages, you can argue that are rare. But there are other situations where these systems might be up, but still not serve us well, right? So for example, there is a situation of no data. For example, when we write our logs to some place and the logging subsystem can't take the logs from there. Or we don't have permission to write the logs to the system where we store logs, or the agent that collects telemetry fails. There are situations of partial data. At a previous workplace, I had a senior developer come to me and say, I know we have a bug in production, but I see logs, but not the logs of the problem. And this was pretty frustrating, and we debugged it, and we ended up finding that we were using the AWS logs driver of Docker that essentially takes std out and std-air and throws them to CloudWatch, but it also does buffering, right? And that specific version did buffering wrong. And it tried to send too large of buffers to CloudWatch logs when there were many logs coming out of the application. So when the application worked fine, it wasn't emitting that many logs, and so these logs went fine. But when there were issues, these logs would trigger the bug and send larger buffers, and they won't be seen, right, in our logging system. And finally, there's a situation of too much data. You all probably experienced it in some time or another. Too many notifications, too many alerts, too many log lines, and we lose sight of the important ones. And so you might argue that what would be the probability of both our production system failing and these auxiliary systems failing? And actually, a lot of the time, these things have correlations, right? For example, they have shared infrastructure. If you remember the 767 APU, it was relying on the same fuel tanks that the engine was relying on. If you've been to yesterday's Meta talk, you know that the system of allowing people into the data centers or the DNS was also relying on the same routers. And it can be the same Kubernetes cluster, right? I've seen people putting their entire observability stack on the same Kubernetes cluster their production application is. And not only shared infrastructure, but also automation. Think that you need to very quickly patch something, maybe Log4j, and then you want to do it across your entire fleet, but there is a bug. And then you take down both your production system and your auxiliary systems. So, and it gets worse, right? And the reason it gets worse is because these auxiliary systems are also have dependencies between themselves. Our ability to autoscale sometimes is dependent on our monitoring system. Because we want to see how much maybe memory is used or how much CPU is used. Our gradual deployment or rollback ability can also be dependent on our monitoring system, because we don't want to deploy this version to more servers until we know it's OK, and maybe we want to roll it back. Some systems have these dependencies in their name. For example, if our people rely on chatbot operations to manage our systems, this is very much dependent on the instant messaging service being up. If we use GitOps, our ability to change our infrastructure as code is dependent on our source control being available. Another story that I've seen is where a team had messages to send to customers that were approved by a marketing department and were legally approved. And they have this system, and if any incident happened, they would be able to send these messages to customers. And then they had an incident, and together with that incident, they also have a problem with their ticketing system being down. And then during the incident, they found out that this system that has the messages and can send them to customers was depending on the ticketing system. And so they had an incident, but they couldn't tell their customers. AWS had something a bit similar recently, where our internal network was congested, and it affected some services, but we couldn't update the service health dashboard because it was dependent on the same internal network. So this might sound a bit bleak. So what should we do about it, right? So I think if there is something that we learned during this conference or in other conferences as well, is maybe the right answer to that question is nothing, right? Not all systems are super critical, and for some of them, it might be just OK understanding that this is a thing, and it can happen, and if it will happen to us, we can say, OK, we understand what's happening now. We are going to take a break and come back when both systems are back. Another option is to take some of the things I'm going to mention now, or add things of your own, right? You don't necessarily have to do all the things, or you don't necessarily, you are not another company, right? You are your own company. So some ideas of things I've did and see being done. So the first problem we mentioned was no data, right? Where the other system is up, but it doesn't have the things we want. And most alerting systems have facilities to handle that. You just need to turn it on. So you need to decide which alerts are as bad when they're breaching threshold and as bad when we don't know what's happening there. And in those alerts, you want to turn on the alerting on no data. We can have an internal status page, right? A lot of people are talking about external status pages, but we can have something that isn't much fancier than this slide on our internal wiki. And each of those dots can be a widget that goes to some status page. And then when our engineers go on a problem and try to debug an incident, they can see what tools are available right now, right? Another idea comes from PagerDuty, from a Roops talk in 2014. They actually created an external page that lightly touch internal systems, and they are monitoring that page using another monitoring system. This allows them, even if internal systems are down or internal monitoring is down, to still understand that something is wrong, right? Also, like a great talk, even from 2014. And this is not something only a paging company would do. This is actually a use case that's been on Site24/7 website for years now, right? So you can do it too. Another thing I've seen done and I recommend is not having that blank page in the manual when these kind of things happen. So you want to go to your playbook and add first some global chapter that describes that situation and who should we contact if it's happened and how should we contact them, and what to do or how to tell people that the incident is over. Because if we have incident in our paging system, then people will start ignore the pages, right? And we want to be able to tell them, look, people, the paging system is back online. If you get any more pages, these are real pages. You should do something with them. And then per application, we want to have something that says, how can we monitor the KPIs of that specific application, or how can we get the logs of that specific application if there is an incident and the monitoring system is out or the logging system is out. If you implemented any secondary subsystems, as an on-call, you want to bookmark those and have them ready at hand. You want to know your customers, because if we are having a production incident and everything is dark, someone, hopefully you, can tell them, look, our system is down. The things you are experiencing might be coming from our system being down right now, and how to tell them we don't have an outage. This kind of relates to the playbook thing. During an incident, some UIs might not be available due to reasons. So have a backup, like CLI commands or directly the APIs you want to call. This is something I've been seeing a lot. So when you configure alarms, you tend to send everything to the paging system. Which makes sense, because in the paging system, we can define we want to see this thing by email, and we want to see this other thing by phone, and we want to get this other thing by app. But if the paging system is down, so you're not getting any alerts anywhere, so a nice thing that you can do is to configure your alerts to go both to an email list and to the paging system, and usually have a rule removing all these emails. But during an incident of the paging system, you will still know what's going on. And you can take that and zoom out and do the same for other systems, right? So if we go back to the Docker logging example, if you're sending all your logs directly to some external system, or if you're sending all your metrics directly to some external system and these systems are out or not available, then during an incident, such incident, you don't have no logging and no metrics. So try to think about having some hooking mechanism. For example, with Docker, there is a dual logging option now. So you can have like a cyclic file that also have the latest logs from the container. Or if you're using Prometheus, then you essentially won because you have an exporter, you have an endpoint that also have the metrics. And they are not only on that remote system. And probably the most effective advice I can give is if you are already running game days, and I hope you do, try to add this type of failures to your game days. For example, on your next game day, try to operate an incident without your Slack. Or try to operate an incident but without accessing the system where you store your metrics or your logs. And this can also be codified, right? If you are using something like Gremlin or FIS, you can, in the same configuration of the experiment, also say, we want to take the policy of read from the operations team to CloudWatch, right? So to summarize the things we can do, not should do, we can watch and should watch our monitoring system. We can have a playbook so people waking up at 2 a.m. are not completely in the dark on how to approach the problem. We can be better prepared in how we design for emergencies, and we can run game days of this flying blind situation. So the takeaways, I guess everything fails all the time. And yes, also the systems we are planning to use while everything fails. And we can be better prepared for that. Thank you so much.